Hi, everyone, and welcome to another episode of Learn with Dr. G. That's me. Today, we are going to be introducing Bash, all its commands, and playing around with it in the Windows terminal. So let's get started. All right, so this stream is going to be following the Microsoft Learn module called Introduction to Bash, which you can find at aka.ms/learnwithdrg/intro bash. A quick recap, Bash is basically the interface between us as the developer or computer user and the system beneath it. So we type in commands and the system performs them for us. Bash is the shell where we can give it the commands and it'll execute them on our machine for us. Bash is a Linux shell, and in the future, I'll make some videos on Bash versus CSH versus ZSH versus PowerShell, but today we're going to be focusing on the basics of Bash. If you've seen any of my previous Learn with Dr. G videos on this What You Didn't Learn in School series, you might have seen us using some of these commands when we were doing introductions to Git and GitHub. You can check those out at aka.ms/learnwithdrg/wydlis_videos. Today, though, we're just going to be focusing on our individual system and running the commands here without any kind of collaboration. I'm currently on a Windows device using WSL, which is Windows Subsystem for Linux. You could be doing these same commands on a Mac terminal or on a Linux terminal, or if you have a Windows terminal with Windows Subsystem for Linux. And if you're excited about Windows Subsystem for Linux, I will be doing, or have already done, depending on when you're watching this, a video on that. You can find it, whether it is coming up or already recorded, at bit.ly/APR13_WSL. So the first thing that I want to point out is that I am currently in a folder called Bash. I created that folder, and I'll show you how to create folders in just a minute. We can see what's inside of this folder by typing ls or list. Right now, there's nothing in this folder, although there kind of is some kind of reference in this folder, and we can see that by typing ls-a. What we've done so far is run a command by itself and a command with options. All Bash commands basically have this same structure, where you type in the command name, followed by an optional list of options, followed by an optional list of arguments. Sometimes you'll have arguments without options, sometimes you'll have options without arguments, and sometimes you'll have neither. We're going to explore a lot of different variations today. When we did ls, that was just a command with no options or arguments. And when we did ls-a, that was a command with one option, which was the A flag. We can actually learn more about ls, or the list command, by typing man ls, which is essentially opening up the manual or the documentation for this Bash command. It opens it up right here in this same window, but to get back to our Bash command line prompt, we do need to type Q to escape out of this. But let's go ahead and explore it for a minute. We can see that the name of this is ls, and the purpose of it is to list the directory's contents. You can see here that we can have ls as the command by itself. There are some options that we can include. And if we did want to include an argument, it would be the location of a particular file, which I'll show you in just a minute. Down here, we can see that the option -a is the one that we used. And what it does is ensures that we're not ignoring any entries starting with a dot or a period, because those are typically hidden files or folders. We actually saw this in one of the Git videos with the .gitignore file. We don't really need to see that. It's not a part of our coding process. It is more a part of our collaboration process and our use of Git. And so we hide that file with a dot or a period before it. And if we wanted to see all of the hidden files, we just say -a when we use the ls or list command. You can see that there are a number of additional options here, and I'll let you browse them on your own. I'll type Q now to get back to our actual command line area. So when we typed ls-a, we did see that there were two additional folders here that were hidden before when we didn't use the -a or all flag. The first folder is dot, and this indicates or represents the current folder that we're in. So dot is this folder. If we were to do ls dot, it would list nothing because that is this current folder. If we were to do ls dot dot, so we're not using any options here, but we are indicating the folder or file that we want to list the contents of, we can see that this lists the contents of our parent directory, which includes the folder that we're currently in, bash, as well as the folder cats, which was from our intro to Git video. ls, we can have options. ls-a dot dot also shows us not only those two folders that are in that parent folder, but dot and dot dot. Every single folder will have those hidden folders or references. All right, another command that I love is clear. Oftentimes when I'm using my terminal, I'll have just a bunch of different commands that are happening and a bunch of different output. And when I'm ready to kind of shift tasks, clearing that out so then that way I'm starting with a fresh canvas is really helpful for me. Don't worry though, they are still above. You can scroll up and see them. And another handy dandy trick, if you are working with a lot of commands and maybe doing the same types of things often, is you can push the up arrow to go through all of the commands that you've run previously and down similarly to come back down. So I can push up and do clear again. I can do this one again. So I just have to do up and then enter. The neat thing here is that if I wanted to, I could say, oh, wait, what was that command again? Go up, say, oh, but I wanted it for this folder, and then type enter. So you can still also edit those commands after you've kind of scrolled up through the list. All right, let's type clear again. The next thing that I want to show you is the make directory command. This is like creating a new folder, essentially. So I'm going to make a directory called test. Now I can see that that directory is inside of my current directory called bash. I can change directory to go inside of the test directory by using cd or change directory. Remember, I do always have the dot, which is the current directory reference, and dot dot, which is the parent directory reference. So if I am currently in that test directory, I can do cd dot dot to get back up to that parent directory or the bash directory. So now you kind of know how to create a directory, list what's in them, go inside them, come back out, and explore your file system using bash commands. All right, now I'm going to make a couple of fake files for the purposes of demonstration. I'm actually going to be using VI, which is a very basic text editor that opens directly inside of this terminal, so it doesn't use any external applications whatsoever. I'll type VI, and then I will put in the argument for the file name that I want to either create or open. If this file doesn't exist, this will create that file and open it. If it already exists, it'll just open it. So I can do something like vi notes.txt. This will open a txt or a text file. We can see here that this is a new file, that there are currently no lines of code or writing or anything like that. And I'm going to go ahead and just write something in here. First thing I need to do is type I, which is putting me into insert mode. I won't be able to write anything inside of this file until I enter insert mode. So I'm now in insert mode, and I'm just going to take a couple notes. To get out of this, I'm going to type escape to get out of insert mode, colon to enter a command for VI to know that I want it to do something. And then I'm going to type two letters, WQ. W stands for write, Q stands for quit. So basically, I am typing colon WQ to say, hey, VI, I am done. I want you to save, write this to disk. I want you to save the contents of the file. And then I want you to quit, meaning close out the VI editor. Now, I could have just done a couple of changes. Maybe I'll add in text here. And then just done escape colon W, and that'll just save my files and keep it open here in the terminal window. If I wanted to continue writing, I can type I again, and maybe I'll get rid of this. And let's see what happens if we tried to do Q without a write. Escape colon Q. Oh, hey, you've made some changes. You didn't save them. Are you sure you want to quit? This is basically that same thing that you get in other applications, whether they are code editors or just Word documents where you've had some changes, you're ready to close, and it's like, hey, do you not want to save? Do you want to save these? What do you want to do here? So it's not going to let me close that. If I really wanted to get rid of all of the changes I just made, I can do :Q and then an exclamation mark to say, yes, I just want to quit this, don't save. And that text word is still there. Otherwise, I would need to do a WQ, and I can do W first and then Q. That's a little introduction into VI. Let's make a couple of other files as well. Just some of the stuff that we've already done. I'm going to go ahead and escape out of here as well. And let's just pretend like we were making a simple little Python program as well. All right, and then I can save this file, escape :WQ, and I could even run this file if I wanted to. This is using the command Python 3 with the argument example.py to execute this Python file. Awesome, pretty cool. Let's go ahead and clear this out. And let's just refresh our memories as to what we just did in terms of creating a bunch of files. All right, so now we have that test folder. We have example.py, examples.txt, and notes.txt. Let's say this was a folder that had a lot more files in it. What we could do is use what's called wildcards. So for example, if I only wanted to show or be able to see all of my TXT files, I could do something like this. The star or asterisk indicates I don't care what comes before .txt. It could be anything, it could be nothing, but I do want it to have .txt at the end. So that'll show only these two files. I could also do something like this. This is going to do any file that starts with EXAMPL. Doesn't have to end in E, doesn't have to end in a certain type of file. So it's going to show us both example.py and examples.txt. What do you think this is going to show? LS asterisk E asterisk. It's going to show everything because every single thing that we currently have has an E in it. Example, examples, notes, and test. All right, I cleared out my screen and I listed all of my files again. I'm going to write a couple of other files just so that we can get a couple of other examples of these wildcards. Okay, now I've got a couple of extra files in here. One of the other wildcards that you can use is the question mark. Okay, so I have two files now, notes.txt and notas.txt. Notes.txt being my English text file that contains notes for this project. Notas, my Spanish version. Let's say I wanted to list all of my text files that were notes, and I didn't care what language it is. Luckily, notes and notas are only one letter off the E versus A. So we can say that I want to list all NOT (s.txt) files where the question mark can be any character. So this will just list those two text files. All right, so there's a bunch of other commands and wildcards that you can try out on that Learn module, but let's continue with a couple of other things. So one thing that we can do is ls-l, and I'm going to reduce the size just for a minute. This is going to give us some additional information about all of our files or directories that are in this current directory. Notice that over here, we actually have a list of permissions. So this is going to be read, write, and execute permissions, where the first set of 3 permissions indicate the owner of that file or folder. The next 3 indicate the group. And then this third one is going to be other, or basically public to the world. And we've got read, write, and execute for each one. So you could change the permissions for the owner or for the group or for the world such that they can only read. And so then these would be lines here to say only the owner can write and execute this file as an example. And then this first one way down here, this D, this indicates that this is actually a directory. And we know that because it's over here, it's that test directory. So we were able to open up files using the VI editor, but there's another way that you can see the contents of files without having to open them up and then close them. So this would be useful if you don't actually need to edit the files, you're just kind of needing to see something in them. So the way to do this is using the cat command. So here's an example where it'll just print the contents of the file right here inside of my terminal window. Here is that little Python file. All right, so what happens if you want to remove a directory or remove a file? So basically delete something. Well, we can do this. Let's say we wanted to remove the readme.txt file. What we do is type rm for remove, that's the command, and then the readme. So I'm just going to type a capital R because in this case, readme.txt is the only file that starts with capital R. Push tab, and there you go, it auto-completes. I can remove that file just like that. Now, remove, you have to be careful because you can't just automatically get this back. So one thing that you can do is use the option -I, which makes the remove command interactive. Let's say I was trying to remove all files that start with E, and I thought that I knew all of the files, but actually I didn't. So if I typed this, and it would say, do I want to remove example.py? And I say, oh, no. Actually, I didn't want to remove that one. Thank you for asking me. But yes, it was that txt file I wanted to remove. So we can see now that examples.txt and readme.txt were both removed. If you want to remove a directory like test, first of all, let's make sure that we know what's in there. You can either change directory into test or just do ls test. Nothing's in there. This is where we're at, ls test, nothing is in there. I want to go ahead and remove that. So let's just do remove directory test. Perfect, it's gone. Now let's say we did have a directory called test. And let's go into that directory. Let's just say that that directory did have a file. All right, so now test does have a file in it. We can go back up to bash. We can make sure that test does have a file in it. I'm going to try remove directory test. Nope, it is not an empty directory, so we can't just remove it. Maybe I'll try just remove test. Nope, you cannot do rm on a directory unless you do -r. -r is a recursive call to remove. So basically this is saying, go into test, remove all of the files, and then remove test. That worked, and now test is gone. You need to be very careful with remove, again, because this is just deleting files, right? A common thing that you might see on the internet that you need to always be very careful of is remove -r. That's great. That's that, recursive remove. F. The F option for the remove command is a force, meaning even if there are files or folders, etc., that the system is going to warn you about that you can't remove for whatever reason, this will force it to remove it and will just remove it no matter what. So this command here, remove -rf star, meaning everything. It can match anything. That's the wildcard for anything. That will remove all the things in this folder. We do not want to do that. You almost never want to do that unless you're really trying to remove everything. So you need to be very, very wary when you're using these commands. All right, let's do a couple of other things. Let's maybe copy example.py over into example2.py. CP is that copy. The first argument is the file you want to copy, and the second argument is where you want to copy it to. Since example2.py didn't exist before, it can easily create that file and copy it over. Now, let's go ahead and take a look at this. Example2.py has this in it, and example.py has this in it, so the same. I'm going to edit example.py over here, and I'm going to say, let's just move this to 8. I want to print it 8 times. Now we can try to copy example to example2 again. Now they're different. So let's try to do that. All right. It simply overwrote it. That can be a problem because if you didn't realize that example2.py already existed, you might have copied things over and overwritten the file on accident. Again, just like with remove, there is a way to fix this. So one thing is, let's go ahead and come in here again. Let's change this back to 5. Let's make sure we know what's in all of our files. So we've got example has it to 5. and example 2 has it to 8. Okay, you can run copy with the interactive option, example.py, example2.py, and this will, if the file that you're trying to copy to already exists and you're about to overwrite the contents, it'll ask you first. So, oh, no, I didn't want to do that. What I actually wanted to do was copy it to 3. In this case, it didn't ask us because example 3.py hasn't existed yet, and so it can just create that file. All right, so this is where we're at right now. Another thing that we could do is move files around. So I'm going to go ahead and create a directory called examples. And now I've got this, and I'm going to move anything that's a Python file into the examples folder. Okay, so move anything, example, example2, example3, anything that ends in .py into the examples folder. And maybe I'll make a directory called like text files, let's just say. And then I'll move anything that is a .txt into the text files. Oops. Clear, ls. Now I've just got 2 folders. Inside of examples, I have these, and inside of text files, I have these. All right, let's go ahead and check out the ps or processes command. ps-e will show us all of our currently running processes. In this case, it's pretty much just bash and that process command that we just ran. You can get a little bit more information with additional flags. ps-ef is going to give you who has executed that process. So you can see that I opened up bash. I actually have another bash window open somewhere else. So that's why there are 2 over here. And then I also did this ps-ef command. Root is handling those other init commands, which is just basically initializing this environment. All right, I zoomed out a little bit because the next command requires more characters across my window. I can type in W for who, and this will tell us all of the current users who are on this server. This is just me running on my local machine, so there's no one running on this, but that's a useful thing, particularly for sysadmins, which in this case, this is just an example of bash commands. All right, let's talk a little bit about I/O or input-output operators. There are a couple in particular that I want to show you. One of them that you can use is this caret here. And this caret here basically says, hi, this is the command you're running, but rather than print the output right here, I want you to put that output into the file wherever I'm going to put whatever I'm going to put right here. So basically it's redirecting the output into something else. So maybe we'll say like file list.txt. So nothing got printed. If I were to type ls without that, we can see that we have these things. And if I were to see what's inside of file list.txt, I can see that that content, the ls output, got saved into this .txt file. Let's say that I were to create another file. Let's say this is just to show the pop-up operator. Save and quit. So ls is this. And if we remember, the file list.txt contains these. So now if I were to do ls and then that caret and then file list again, we can see that it just has exactly what would have been printed with ls, which includes the examples folder, the text files folder, the file list.txt, and the test.txt. But let's say that you were, instead of outputting just the contents of ls, let's say you wanted to have the output for a function that was gathering new users or gathering timestamps of something or something like that saved to a file. You don't want to overwrite that. You might want to concatenate that to the end of the file. So we could do something like this with the 2 carets. And now when we show the file list contents, we can see that it is like doubly long. So we have the first one and second one, the first one here at the top, and then the second one, the second set of output here. They're the same, so you're just kind of repeating them, but that's what happens when you use that double caret. It's kind of a concatenation operator. Okay, so this is what we have in our file. We can do a couple of other things as well. So we've already shown how you can run a command and pipe that out, the output out into something. Another thing that you can do is like kind of pipe something into something. So running sort and then the caret going that way, file list, that's going to sort all of the lines in that file for us. So we could have sort file list, and we know that the output of this, because we just saw it, is this sorted list. Then we can say, I want that output to go into the sorted file list.txt file. So now sorted list has this, file list has it in that original sort, and this is what we have inside of our folder. All right, let's play around with it a little bit more. Let's do all of our processes that are currently running. And you know what? I only want to see all of the processes that are currently running, but I also want you to only look for things that are being run by the root. So here we can see that there are only these things that are being run by the root. So that's a really great piping there, which basically will pipe the output of ps-ef, which is that full list, into the next command set, command with argument grep. Grep is a command that searches for a particular string. So I'm saying I want to grab this whole output and then searching for that particular string root and only output that. We can do all of that and say maybe like root commands.txt. And there they are. So you can see here that you can really just continue to add on to all of these commands with the different input output, as long as you know what's happening where, and you can kind of test that out while you're doing it and build up these commands as they make sense. So this one, for example, is just the command ps with the arguments ef. That output gets piped into this next set, which is grep command with the argument root, which then gets put into this file roots commands.txt. And those are really some of the basics of the bash commands. So I highly encourage you to check out the Learn module at aka.ms/learnwithdrg/intro bash and try some things out for yourself. I do recommend doing it in a test folder like I did here, just in case you accidentally do an RM of something. But these are some of the commands that you can use. And as always, if you do try this out and you are excited or you just did it and you want to share that with me, please feel free to. I'm at Dr. Guthels on pretty much all social media, or you can use the hashtag LearnWithDrG. As always, thank you so much for joining me, and I will see you next time. Bye, everyone.